and this is my data mining project for text classification on the Reddit data. So first of all, I'm going to advertise this. Why you should follow the steps that I followed is because I have covered more than four. That means five. So I've covered five total algorithms, and some of the algorithms that I've covered are naive-based classifier, support vector machines, deep learning models, logistic regression, random forest classifier, and I also done feature engineering using TF-IDF and bag of words. Okay, so let us understand why we need to do text classification in machine learning models. Nowadays, you can see that there are spam emails, so there are many different kind of sentiment analysis that needs to be done. And for this project, we are doing text classification because we have the Reddit data, we have the Reddit comments, and we need to see if the comments can make or comments can classify what label the post uh, depends to. So some of the classifier we have used are the naive-based classifier. We have used the naive-based classifier because of its simplicity, its naive structure. The naive-based classifier is called naive basically because uh, because it considers each of them to be an independent to each other. So that is why it is considered a naive, and it helps a lot in text classification. So let me show you how we have done this. This is about our data set. It's the data set is already up on the Kaggle, but I've still mentioned the link over here. Okay, this is a link to my GitHub repo. You can go over there. We have imported the libraries. We have pre-processed the data. We have pre-processed the data using Beautiful Soup, using regular expressions and using stopwords. So we have done that. And once we have done that, then the first problem that I faced today while doing this is the text classification. While doing the text classification is that the labels and the data was in the different sections. So I merged them. So I've also shown the steps on how to do it. So that is how the naive base works. The posterior is equal to prior into the likelihood divided by evidence. So that is how it works. And it can give us an approximate accuracy of 70.98%. That's nearly about 71%. And this you can see right over here, this arrays, right? This arrays, they are basically the prior probability, which has been calculated by the multinomial naive base class, and they have been shown over here. So that is how this has occurred. Okay, the next classification is that the random forest classification. Okay, so why do we use random forest classification? First of all, the random forest classification makes so many different decision trees and compares them, and that is why it is one of the best classification to uh, to challenge the overfitting problem if you are facing. So random forest classification, even if you change your parameters too much, it does not overfit so much. It will only show a little bit of change in accuracy. So that is how random forest is helping us. Classifier is working, so that is why I choose that as well. So these are basically the gene indexes and how it works so that you can understand from over here. We have also supported neural net. Okay, so neural net, as everyone knows that neural net is a very big concept, right? We need to create a dense layer, we need to create a convolutional layer, we need to create a global pooling and dropout and so many things. But neural net is also very similar to random forest classifier. It does not overfit very much, and it helps us in even in seeing that if the model is overfitting with keras. So that is why we have used that. We have used a relu and a software function over here. Okay. Mm, So let us see any other support vector machines. Yeah, another popular machine learning algorithms is support vector machine. Um, it helps in identifying the hyperplane. So it basically helps in identifying the hyperplane that divides the two classes. So SM can also handle high dimensional data and effectively dealing in non-linearity separable data. So that is why we give support vector machines also a very good chance. Okay, so that is why we have done support vector machine over here, and it definitely does, because the neural net could only give an accuracy of 65 to 66%, but the support vector machine gives us an accuracy of 69.20 percentage. So that's a very good percentage. We have also done logistic regression to see if logistic regression can give us a good accuracy, because the logistic regression has simplicity, effectiveness, and interpretability. It's binary classification algorithm that models the probability of the given input belonging to a particular class. So based on those values, its features are defined and the text classification is done. So that is a very good point over here. So that is why we use linear regression, but it only gives a 68% accuracy. So these are all the comparisons between the models. This is the uh, this is the engineering that I have done. I've used a TF-IDF instead of along with count vectorization. So we'll directly jump to the results. So these are the results. So in naive Bayes, it decreases, the accuracy decreases, but in 2 to 3 models, just like in random forest classifier, in neural net, and in logistic regression, the accuracy increases by a lot. So that's something where that uh, the feature engineering does. Okay. Then we also have hyperparameter tuning. So this you see right over here. When we fit our parameters too tightly, that is when this arrow occurs. This is called overfitting problem. This is basically how it works. So this is hyperparameter tuning in naive Bayes. This is hyperparameter tuning in random forest classifier. This is hyperparameter tuning in I think it's in support vector machines. That is correct. So these are all the various things that you could see, and that is why you should follow my notebook, which is available on this blog post. And you should also read the blog post. I have described everything why you should do this and what will help you to increase your overall accuracy. So thank you and have a nice day.